Hello, ladies and gentlemen. Today we are going to take a look at similar figures and what it means to be similar. So for this, you're going to need your calculator, your pen or your pencil, and as well as some notes. We're going to take a few notes, and then when we get to class, we'll do some practice. So let's think about if I place this shape into the copy machine and have to reduce it, I want a reduction. I want a smaller version of this same shape. You know what it would look like when it comes out of the copy machine. I mean, you can picture that. This would not be a good situation. The copy machine does not shrink the angles in half. This is not what comes out of the copy machine. It is a miniature version of the same shape but a different size, right? So to make a larger or smaller version, we need to keep in mind that we don't change the angles. We don't add or subtract from each side. The only thing that works is to divide or multiply by a certain number. This keeps the shape proportional. Into your notes, I need you to write down this definition, the definition of what it means to be similar. Similar figures are polygons are similar if they have corresponding angles that are congruent, so if their angles are still equal, and the ratio of their corresponding sides are in proportion. So that means we're looking for the sides to have the same ratio relationship or proportional relationship. If the two polygons are similar, then the ratio of the lengths of two corresponding sides is called the scale factor. So if we know that they're similar to each other, we then compare two corresponding sides to determine, how much smaller one is than the other, that sort of thing. So here's example one, the first example you need to get into your notes. Here we have two shapes. They are similar. We can tell because the angles are the same here. And if I were to set up the ratio of each of the corresponding sides, in this bigger shape, the 6 side on top would match up with this 4 side over here. XY and QR would be corresponding sides. Just like the 9 over here would match up with the 6 right here. So I'd say 9 over 6. Just like the 12 matches up with this 8. 12 over 8. And just like the 15 matches up with the 10. 15 to 10. So when I make all these ratios, to determine if you have similar polygons or similar shapes here, you want to make sure that these are all the same reduced fraction. So if I reduce 15 over 10, I get 3 over 2. If I reduce 12 over 8, I get 3 over 2. If I reduce 9 over 6, I get another 3 over 2. And if I reduce 6 over 4, I get 3 over 2. That means that all the ratios are the same, therefore the side lengths are proportional, and this example is one of similar figures. So the scale factor, when you compare one shape to another, is this reduced ratio that keeps coming up. All of these sides reduce down to 3 over 2. So the scale factor would be 3 over 2, or you can write it as 3 to 2, like so. The similarity statement would be us saying that these are two similar figures for certain. So x, y, z, w in the first figure is similar to q, r, s, p. The order of those letters still matter, ladies and gentlemen. Notice the symbol here for similarity. Okay, this means similar to. Not congruent because it doesn't have the little equal to's underneath, right? I mean, that's what's missing. It's not equal, it's similar. So similarity statement is us saying that one is basically a bigger or smaller version of the other. Let's look at this example. Are these figures similar? Okay, be careful when you set up these sides. We need to make sure they make sense. In this bigger triangle here, the 10.5 is the smallest side. The smallest side over here is 4. The medium side in the bigger triangle is 12. That would compare to the medium side over here, 9. And the largest side, we want to say 18, compares with 12. So if I want to decide if these are similar, you didn't need to write this one in your notes, and that's okay if you're not. You want to reduce each one. So 18 over 12, what does that reduce down to make? Okay, I can divide both of those by 2, 9 over 6, I can divide both by 3. Okay, you can reduce it one step at a time. 3 over 2, okay, could have divided both by 6. This one right here can divide both of them by 3, so 4 over 3. Already I'm noticing that these ratios are not the same. Because they are not the same, because those fractions did not reduce to be the same, these two figures are not similar to each other, okay? We have to check those sides to be sure that they are the same ratio or proportional. What about this rectangle and this rectangle? Well, the small side here is 8, matching up with the small side here, 3. Just like the length or the longest side, 15, longest side, 10. Now, if I look at those two fractions, are they in fact equal? No, 8 over 3 is not equal to 15 over 10. So again, these are not similar figures. We're checking that ratio. So here's the second example I need you to get into your notes. This is a situation where we know for certain that these two lovely figures are in fact similar to each other. We have TUVW is similar to ABCD. These are trapezoids here. And it says that we are to find the scale factor of TUVW to ABCD. So the scale factor means basically comparing one to the other. How do they compare? So to find the scale factor, I need to choose a side from this figure because it's listed first. I think I'll do 15 here. 15, and then I will choose a side that corresponds to it over here, the 9. Now 15 to 9, I wouldn't leave that like that. I'd reduce, divide them both by 3. The scale factor is 5 to 3. Okay, that means the larger one compared to the smaller one, as it asked us to do, is 5 to 3. Now, how can we use that to find the length of TW? TW is this side over here in the bigger one. Let's pretend there's an X right there. Using our understanding of proportionality and proportions, we should be able to solve for that X by setting up something we could cross multiply. Like this 9 matches up with or corresponds with that 15. So if we were to make a ratio with those, that ratio would be the same as if I compared the 6 with the x. So 6 over x. Now if I cross multiply, I'd get 9x this way. 15 times 6. Okay, 15 times 6 is 90. Oop, here we go. Let me get my equal sign back there. 15 times 6 is 90. Divide by 9. And we'd end up with 10. So this measurement right here would be 10. Let's find the measure of angle TUV. That's this angle up here. Now keep in mind with me that angles are not proportional. The definition of similar says that the angles are congruent in one figure to another. So if I use the only angle I've given here in this little figure is 70, that should help me figure out what this angle is up here. And I'd want to know that angle because it corresponds with this one over here. They'd be congruent. So because these two angles, notice, are in between two parallel sides here, check that out. That means because they're on the same side of a transversal in between two parallel lines, they are same side interior or consecutive interior angles, and they will add up to make 180 degrees. So this has to make 110 degree angle there, and then it corresponds to the angle over here, so I would know that that is 110 degrees. Okay, so that's our second example. Our third example, I need you to write into your notes, looks like this. This one's going to involve a little bit more algebra, but that same idea of corresponding, matching, setting up ratios. We have that triangle CDE, the big triangle here, is similar to triangle FGH over here. They're similar. Now that's the big triangle here, and the big triangle over there, right? Now there's a line drawn right here down the center perpendicular and drawn right here in the triangle perpendicular to the opposite side. That's called an altitude. It's the height of the triangle essentially, okay? That altitude right there is also proportional with the sides. So a key fact that a lot of people don't think about is if two polygons are similar or if two shapes are similar, Other things have that same ratio relationship, like altitudes, medians, diagonals, angle bisectors, perimeters. They're all in the same ratio. Okay, so be thinking about that here. We can use cross multiplying here as long as we set up corresponding pieces. So in the small triangle, if I'll give you a second there to write that part down over there before I continue my algebra. Okay, I'm going to make it go away. Whoop, back. Now in the small triangle, let's set up those altitudes here. 7x would go with the 9x. The altitude in the little triangle goes with the altitude in the big triangle. Just like the side in the little triangle goes with the side in the big triangle. Okay, so setting up our cross multiplying isn't too bad. Now, once we set up those sides, now here's where the algebra comes in. If I cross multiply this way, 7x times 10x plus 1, 7x times 10x would be 70x squared. And 1 times 7x is another 7x. And cross multiplying this way, 9x times 8x would be 72x squared. And 9x times 1 is negative 9x. So with this in mind, we'd want to go ahead and get our x's together on one side. So I think I'm going to bring them over there to the left. I'm going to take these x squareds actually and move them over here to hang out with those. So I'd have 2x squareds minus 9x's plus 7, or equals 7x. Now I want to bring those x's over to be on the other side. So I'd end up with 2x squared minus 16x's equal sign 0, because I would subtract them over to the other side. Okay, so here's where we're at. We got our x squareds and our x's together on one side because why, ladies and gentlemen? Because we have an x squared in this problem, which means we are going to get two solutions, and we need to use factoring to make that happen. Okay, we're going to first factor out a greatest common factor. 2x squared and 16x can both be divided by the number 2 and an x. So I'm going to divide out a 2 and an x from what you see there, and I'm going to write what's left in these parentheses. If I divide 2x squared by 2 and an x, I'd be left with just 1x. Notice that 2x times x is 2x squared. I'm factoring. I'm not dividing away anything, okay? 16x divided by 2x, well, 16 divided by 2 is 8. X divided by 8 would cancel to make 1. So I have now factored this expression by taking out a greatest common factor from both of those terms. Now, the reason I do that, remember, we've talked about factoring already this year, is to get my two solutions, I need to solve two simple problems here. I have an x minus an 8 would equal 0. That one's pretty easy to solve. I'd add 8. Zero product property, okay, says that each factor is going to equal 0. I get a solution of 8 for one of x value. Now this piece out here also needs to be set equal to 0. And if I divide by 2, I get x to equal 0. Remember, we said there were going to be two solutions. So I have an x equals 0 and I have an x equals 8. The only problem is that in this situation, if I stuck a 0 right here in one of my triangles, actually on the altitudes here, I get an altitude of 0. That doesn't make sense. So I'm going to cross that one off. The only solution that works in our situation is that 8. So be thinking about factoring sometimes when you have that x squared in there that happens. Factoring is a nice tool we want to use in order to solve for x. Okay, so similar figures, we match their corresponding sides, we cross multiply, we set up those ratios and practice those algebra skills. Okay, I want to thank you, ladies and gentlemen, for taking good notes today.